Hello students, now we are going to discuss one of the important chapter, numerical methods. So these numerical methods have wide applications in the field of engineering. Now, as per our syllabus, we are taking one of the concept called finite differences. So here finite differences are important theoretical tool for obtaining formulas needed in the study of interpolation, numerical differentiation, and numerical integration. So here, so this finite differences we use as a tool for interpolation. So interpolation is the process of finding the value of the unknown. Suppose y equal to f of x is a function. We are going to find the value of y for some values of x. So that process we call as a interpolation. This is also one of the important topic. Then numerical differentiation. So numerical differentiation is what? So already we studied some basic methods to find the solutions of the differential equations, either the first order or second order, even the partial differentiation. So in now using numerical methods we can find the solution of differential equation. This is also the one of the application of the numerical methods. Okay, and also numerical integration. This is also one of the good application of the numerical methods, that so whenever the integrals are given, we directly integrate by using some of the basic methods like substitution method or some many other method. Then we can evaluate the given integrals. Now with the help of numerical methods we can evaluate the integrals. Okay, so these are the some applications of the finite differences which comes under the numerical methods. Okay, now suppose that the function y equal to f of x is tabulated for the equally spaced values of x. For example, the values of x are x naught plus h, x naught plus 2h, so on, x naught plus nh. So these are equally spaced values of x. So where h is the difference between the values of x. Equally spaced means the differences between the values of x must be same. So this is x1, x naught plus h, where h is the difference, and this is what our x1. This is x1. Then x naught plus 2h, this is x2. Even this x naught plus 2h we can also write as x1 plus h. Likewise we can write x3 as x2 plus h, keeping the difference h we are adding to the previous value, like x0, x1 is x0 plus h, x2 as x1 plus h, we are adding the difference. Then x3 is x2 plus h. Likewise we can write the values of x, or in another way x2 we can also write as x0 plus 2h, x3 as x0 plus 3h, like that. This is xn, this is xn, xn is x0 plus nh. Okay, so here the differences between the values of x are same, so that's why these are called equally spaced values of x. So from these values of x we obtain the values of y as y0, y1, y2, so on yn. For and remember that x0 and y0 represents the first values of x and y. Okay, x0 represents the first value of x, y0 represents the first value of y. Similarly, the second x1, y1, x2, y2, x3, y3, like that. Okay. Next, to determine the values of f of x, that is y, for some intermediate values of x. Intermediate values of x means from these given values of x. For example, if we have the values of x as 0, 2, 4, 6, 8 and all, then we find the value of y at x equal to 3. So 3 is what? It's the intermediate values of x. Okay. There are three types of finite differences. The one is forward differences, second one is backward differences, and the third one is central differences. Okay. Now, depending on the given values of x, we apply the forward or backward or central differences. Now, individually we discuss what is a forward, backward and central. Okay. And remember that for our syllabus we have only forward and backward differences. Clear? Now, what is the forward differences? See, the difference is y1 minus y0, y2 minus y1, y3 minus y2, so on yn minus yn minus 1. When the values of y are given as y0, y1, y2, so on, first we take the difference like y1 minus y0, y1 minus y0, this is the one difference. Then y2 minus y1 we take, then y3 minus y2. This is the way we take the differences of the values of y. Okay. And these differences we denoted by delta y0, y1 minus y0 as a delta y0, y2 minus y1 as a delta y1, y3 minus y2 as delta y2. So these are the notations here. Okay. And yn minus 1 as delta yn minus 1. So these are the notations for these differences respectively, and these are called first forward differences. So these are called the first forward differences, where delta is the forward difference operator. Thus, the first forward differences are denoted by, so we have a notation for the first forward differences that we write in general as delta yn equal to, the difference we take as yn plus 1 minus yn. Okay. So whenever we have simply delta, so this is called first forward differences. Similarly, the second forward differences are denoted by delta square yn. So if there is a square for the delta, these are called second forward differences. Remember that. Okay. And these first forward differences are in terms of values of y. Then these delta square second forward differences are in terms of first forward differences, delta yn plus 1 minus delta yn. Okay, these are in terms of delta. Okay, so therefore in general, mth forward differences delta raised to yn, which is in terms of m raised to n minus 1, m minus 1 forward difference, that is delta raised to m minus 1 yn plus 1 minus delta raised to m minus 1 yn, defines the mth forward differences. Okay, this is the way we write the forward differences. Okay, now, so these all differences what we discussed, so that we put in a systematical table form. See, this is called the forward difference table. See, these are the values of x and y. Okay, the values of x and y are given. The values of x we denoted as x0, x1, x2, so on up to, we considered up to x5. Then y, the corresponding values of y are y0, y1, y2, so on y5. So as we just now we discussed how we take the first forward differences, that we denoted as delta y. If there is a delta, these are first forward differences. Then we take the difference y1 minus y0. If we take y1 minus y0, that we write here, notice that this value we are writing middle of this, middle of y1 minus y0. Here we write delta y0. Then y2 minus y1 we write between the middle of these here as a delta y1. Then the differences of y3 minus y2 as a delta y2. Then y4 minus y3 delta y3. Then y5 minus y4 delta y4. So these are the first forward differences. Okay, then the second forward differences we write as delta square y. Then we take the differences of these two, delta y1 minus delta y0. Do not take reverse. We take delta y1 minus delta y0, that we denoted as delta square y0. Similarly, delta y2 minus delta y1 as delta square y1. That value we write in the middle of this. Okay. Similarly, the other differences, these are called the second forward differences, and these are called the third forward differences. Then fourth, till how many differences we consider till we get a single value. Till we get a single value, we continue the forward differences. Okay, when we get the single value, so that is the last fifth forward differences. Okay, now, so these are the notations we put in the table, but in the problem, these values of x and y are the numbers we are getting in terms of numbers. Okay, so when we take the differences, so y1 minus y0, so we are getting some numbers in the table. So with the help of this table, we are going to find the value of y at some given value of x. Okay, now the second one is backward differences. The backward differences, again these are same, taking y1 minus y0, y2 minus y1, y3 minus y2, y4 minus y3, the same way we take the differences. Then where is the difference here? Only the notations, that you please remember. Y1 minus y0 we take, and here we denote as a delta y0, but in the backward difference, on simply the notation is different. The notation is what? Del y1. There the difference we call as a delta y0, but here it is del y1. We read this as a del y1. Okay, similarly del y2 and so on. Okay, so here with this table I explain, if there are numbers in the table, forward difference table and backward difference table are same, but when we use the notations, see y1 minus y0, forward difference table we write as a delta y0, and in this we write as a del y1. Y2 minus y1, there we write as a del y1, delta y1, and here we write as a del y2. That is what the differences is in the notations. Okay, so this is called backward difference table. Okay, so this is about the introduction about the finite differences. Okay, so for the syllabus we have only forward and backward differences. Okay, we do not have central differences. In the next video we are going to discuss the interpolation. Okay, thank you.